So in this video, we will discuss an example of the system. So consider this advertisement. So we can see that here's a computer have the several parameter and specification of the system. Intel i7 quad core, 3.9 gigahertz, and so on. Okay, so there's many terms in this advertisement: gigahertz, gigabyte, USB, PCI, L1 cache, and so on. So you try to understand what it all mean, and how can we compare different system with different parameter, which number larger or smaller is better. So we can see in a how can we measure the system performance. Okay, so in order to evaluate or to determine which system is better than the other one, we need to have some kind of measure or some quantify parameter in order to quantify the performance of different system. So in terms of measure of capacity and speed, we have the kilo that have the denoted by capital K. That's 1,000. In terms of the speed, that's gonna be 10 power 3. In terms of capacity, gonna correspond to the number of 2 power 10. A mega denoted by the capital M. That's corresponding to the value 1 million. So if that measures speed corresponding to the number of 10 power 6. If that's associated with the storage capacity, gonna correspond to the number 2 power 20, and so on. Okay, so you have giga, tera, peta, exa, zeta, and iota. So the first parameter right here corresponding to the value measure in speed, and the second value right here corresponding to the measurement in terms of storage capacity. Okay, so that's going to depend on what type of parameter we are talking about. So that have the different value. The next measurement we can have that a hertz. So that's corresponding to the clock cycle per second. That we call frequency. So for example, 1 megahertz will have a 1 million hertz. So this means we have the 1 million cycle per second. So basically, the processor of a computer system speed are measured in megahertz and gigahertz. And so this one gonna be speed megahertz corresponding to 10 power 6, and gigahertz correspond to the number of 10 power 9. Okay. On the other hand, we have the byte. So that's a unit of storage. So we know that 1 byte gonna be 8 bit. And now we have this 1 kilobyte. So the kilo right here associated with the storage capacity. So that's corresponding to the number 2 power 10. And that's equal to 1024 bytes. 1 megabyte of storage capacity corresponding to the value of 2 power 20. So that's going to be 1,048,576 bytes, and so on. Okay. 1 gigabyte corresponding to the number of 2 power 30. Okay, bytes. So the main memory, basically that the RAM is measured in gigabyte, and this storage is measured in gigabyte for small system, and the larger system basically gonna be measured in a terabyte. That's the 2 power 40. Okay. Some other measure of time and space also can be used. For example, milli, or that's the lowercase m, so just 1,000th, that's the 10 power negative 3. Micro, that's the 10 power negative 6. Nano, that's a 10 power negative 9, and so on. Okay, so you have the other measurement as well to measure the time and space. So now what are the conversion between the different unit. So for example, 1 millisecond gonna be a 1,000 of a second. This means a 10 power negative 3 of the second. Okay, so basically we have the hard disk of a computer system. I have the access time around the order of 10 to 20 milliseconds. The nanosecond is mean 1 billionth of a second, so that's corresponding to the number of 10 power negative 9 seconds. And that we basically in our system we have the main memory access time are often from have the order of 50 to 70 nanoseconds. In micron, that's the 1 million of a meter. So basically that's used to measure the size of the circuit and size of the chip. So we note that a cycle time is a reciprocal of a computer clock frequency. So basically, for example, if we have a bus operating at the clock frequency of 133 megahertz, that's corresponding to the cycle time of 7.52 nanosecond. Right? So basically, the cycle time gonna equal 1 over 133 megahertz. So we can compute that number equal to a 7.52 nanosecond. Okay. So now back to the advertisement we had at the beginning. So now you can see that the first slide right here, Intel i7 quad core 3.9 GHz. So that information indicate the microprocessor information of the system. So this saying that the microprocessor execute program instruction with the speed of a 3.9 gigahertz. So the larger number of the running or the processing time, that's the better. So it means the system of the computer can finish the work faster if compared with the lower the system with the lower number. Also, we can see that the computer with larger main memory capacity can run a larger program with greater speed than the computer having smaller memory. Basically, RAM is the node for the random access memory. So random access mean that the memory content can be the memory content can be accessed directly if you know its location. Cache is a type of temporary memory that can be accessed faster than the RAM. So basically, the computer may have several cache memories that close to the CPU. So can help the system improve the performance of the system. So the next information right here that denote the information of the RAM. So basically, this information saying that this system have the RAM capacity of the 32 gigabyte, and the type of the RAM, that's synchronous dynamic RAM, so SDRAM. This the second line right here saying that there's two levels of cache memory. The first level, that's the we call L1 cache, that's with the smaller capacity and probably faster. And there's a larger L2 cache with the capacity of 2 megabyte. So we should notice that the capacity of the cache memories is much smaller compared with the main memory and also with the hard disk drive capacity. So the nice information we see that is saying that the storage, the hard drive of the uh, system have the capacity of the 1 terabyte, and the next parameter right here saying that the rotational speed of the disk, that the um, 7,200 revolution per minute. Okay. So definitely the larger number or the higher number, greater number of the RPM, that's gonna be a better performance, because that allows the system to access the information on the hard disk drive faster than the system with lower number of RPM. Okay. Also, we can see that the standard of the hard drive is the saying that ATA. So that's the note for the advanced technology attachment, which describe how the hard disk interface with the other system components. Also, we can see that the system have the DVD player. So that's has the capability of read and write multiple times to the DVD disk. And the number of 16 right here, that denote the speed of the read and write of the DVD. We also can see that the system has the several ports that allow the movement of data between the system and its external devices. So basically, you can see right here that the 10 ports that allow the system connect with the connect to the external devices. So we have the 4 USB ports, 1 serial port, 1 parallel port, 4 PCI expansion slot. Okay. So the serial port that basically allows the system send data at a series of pulses along 1 or 2 data lines. So this one is you can save number of a line for data transmission, but the data gonna send one by one. Okay. On the other hand, the parallel port send data simultaneously at a single punch along at least 8 data lines. Okay, so that the two different ways to sending data between the computer and the external devices. On the other hand, the USB, that's a universal serial bus, that an intelligent serial interface that is configuring. This support a much higher transmission speed compared with the serial ports and also the parallel ports. We also have to see that the system have a two PCIe, that's an express device. So that basically allow the system connect to the video card and also the sound card to for display and for making sound in the speaker. So we also can see that the monitor system of this one, that's a SVGA. So the resolution of this monitor have the 1280 times 1024 pixel. Okay, so that's the resolution of the monitor. So basically, that is some of the key and basic information of a computer system. So throughout of the remainder of the lecture, we can see how the component work and how they interact with the software to make a complete computer system. So while reading and learning some information so far, we may wondering how can we assure that the computer component will operate as we expect, because we can see that many component, and that's very sophisticated component and devices. And how can we assure that the computer component can operate as we expected? And also another question is that how can we assure that all the computer component will operate together? Okay, because now you can see that the computer system gonna be integrated of multiple computer components and devices. So how can we check and ensure that all the components work smoothly with each other? So we can see what the kind of a practical approach allows you to build and also to verify all of the components work correctly and work with each other smoothly in the following lectures.